Well, hello there. This is Mark Osborne, the Senior News Editor for PV Tech. I'm the moderator for this PV Tech webinar with Jinko Solar. Our presenter today is Andrea Viaro, Head of Technical Services and Product Management for Europe for Jinko. And the title of this webinar is Leading to the Ultra High Performance Era, Minimizing LCOE and Maximizing IRR with Jinko Solar's new Cheetah series. From my own perspective, to give you an idea, the Cheetah series is the latest high performance range for the company. It's their mainstream product for the next few years, and this is nothing to do with Bifacial, but this is a very important product because it really is the mainstream high performance module that's going to be backed up with a whole range of technology for utility scale to residential to all the way through to commercial industrial. And I think it's very significant that Jinko have asked us to really give people the first true opportunity to delve into the technology behind what the modules can do. So without me spending any more time, please, Andrea, will you start the webinar?
Yes, absolutely. Thank you, Mark, for the very nice introduction, and thanks for this opportunity to, as you said, to introduce to the market this new development, which will become, at least for Jinko Solar next year, mainstream product as main production, mass production for mono PERC, the Cheetah series with the large cell technology. And we will go through this presentation giving to the audience more in-depth details about the technology itself, the features of this particular product series, and all the benefits that are coming and arising from using this new technology compared to the traditional technologies we used in the past. As a start, summarizing quickly what is Jinko today for the audience to be familiar, and update about the company situation and the mentioned global. Jinko Solar is a global manufacturer with global footprint also in terms of sales offices and representative. Our modules have been deployed in more than 80 countries, just to give you the idea of how flexible and absolutely global are the products to be installed in any possible climatic condition and climatic zone in a reliable and high performance, of course, installations. The production capacity in 2017, of course, it was almost 10 gigawatt already. Now this year, we will close the year with likely 12 or a little more gigawatt of production capacity. But next year we are rapidly expanding to much higher production capacity. An important aspect is the fact that all the expansion plans and expansions that happened in the last couple of years at Jinko Solar focused exclusively on mono PERC, monocrystalline and mono PERC capacity in particular, which together, of course, with the Cheetah technology that we're talking about today, will be really the mainstream and most common modules used going ahead. The transition to mono PERC, not only to mono PERC, but to whole the diversified product portfolio that Jinko Solar can offer today, is of course allowed by the huge R&D investments and efforts that the Jinko Solar R&D team and the corporations with global universities and institutes allowed us to achieve. The investments that we allocate for R&D activities every year takes a really significant amount of our gross margin. And you can see also in terms of staff and technicians, engineers, scientists that we employ directly into the company, the trend is clearly growing. But most important is probably the fact that the laboratory of Jinko Solar is a state key laboratory, which is part of a network, really selected network of laboratories, key laboratories in China, of which comprised of universities and really high-end research institutes, which probably a few other manufacturers can also claim of. Research and development is not only about finished product and not only about efficiency of PV modules, but a lot of focus is on the quality and reliability of production and products. And of course, a key fact to have a high quality product is to use high quality components. First class components such as most durable possible backsheet, for instance, or EVA for module lamination, but also sometimes probably not so considered important, but actually which play a significant role, components like the multi-contact connectors. So by using, for instance, original components, we can really make sure that we deliver the best quality possible to the market. And the fact that we use high quality components and high quality production processes is actually related to probably the key topic of the webinar today, which is ultimately the levelized cost of energy or electricity. Because we are probably used to talk about LCOE in terms of related to initial investment, CapEx, and initial cost of components, not only modules, but of course all the components the PV system is made of. But sometimes probably it's not so highlighted or not so paid attention to the fact that also system lifetime and reliability, durability of the components used for the installation play a probably much significant role than the initial cost of the modules and the components. And that's because, of course, having a reduced or extended lifetime of the components of the modules, we can significantly reduce or affect the LCOE or the business plan of the PV plant that we installed. And just making a rough estimation, thanks to DuPont for the support on this estimation. So just to name that, to validate somehow the estimation that we didn't do only ourselves, but also from an external party. Just to give you an idea about how the durability of the modules can really impact significantly the LCOE. If you look at the right-hand side of the chart, you see that, of course, taking into consideration a theoretical lifetime of modules of 25 years, which is the warranty validity, basically, if modules fail or for any reason don't perform according to expectation or according to business plan, and they stop working or probably not done performing up to expectations after 20 years, you can see that LCOE is proportionally increased, basically compromising completely the whole balance of the whole business plan. On the same side, of course, if modules, as we assume, and of course we produce and design modules to actually last in the field actually much more than 25 years. Of course, if modules last for 30 years, even longer, of course the LCOE is positively affected, but not only. Now, of course, durability is one of the aspects, focused more now on efficiency, which is, of course, one of the main feature of the Cheetah series, the higher power class. We can, of course, impact positively LCOE, increasing the performance of the system, therefore energy yield, kilowatt hour per kilowatt peak installed, and for instance, using a module with a higher efficiency compared to a traditional, for instance, 18% module, using a PERC technology targeting almost 20% efficiency today. Also, LCOE can really be significantly reduced. And even looking at future technologies that we will see available in the future, like shingle modules or TOPCon, or even more advanced technology that will be implemented in mass production. Of course, all these factors can play a significant role to reduce the cost of electricity. Just to mention the possibility, of course, available today to use not only high efficiency product, but high performance product, which can increase by 10% of 20% the energy production of the system, like bifacial solutions or bifacial combined with tracker solution. That's also, of course, a technology which is already mature, available already today. And just to link to a different topic that we'll be discussing in a different occasion, but you can see also here how significant can be the impact on the LCOE. Mentioning bifacial because, of course, they are part of the portfolio of Jinko Solar today, which is much more diversified than in the past. We were used to see at Jinko as a mainstream polycrystalline 60 or 72 cell module manufacturer, but nowadays you can see here summarized, for instance, for the 60 cell series only, the wide wattage range that we can cover with all the different solutions, from 270 watt peak up to 330 watt peak, with the same module format, with different add-on technologies at module level, different cell technologies, including polycrystalline, monostandard, and mono-PERC, which, of course, just to restate again, we believe will be the mainstream product going ahead. Of course, a wide portfolio available at multi-gigawatt scale mass production, which is also something really important to highlight. The fact that all the portfolio, all the products that you see here shown on this slide are available and produced at a gigawatt scale at Jinko Solar. So you can just have an idea about the complexity of managing all this portfolio, and of course using them for a big utility park, which allows us to have a long track record for all the series that we can offer, and all controlled, of course, with the most advanced and most accurate quality control protocols that we use for all the series and in all the factories that we use for module production. On the right-hand side of the chart, on the top right side of the chart, you can see the high efficiency series products, which include, of course, all the PERC solutions, mono-PERC in particular. And at the top of the chart, you see the Cheetah series, which is the series we are going to present today. As the top module, the most powerful module that Jinko Solar is able to supply at the moment in both full cell and half cell configuration, 60 cell, 72, and maybe even bifacial in the near future. So I stop right now for a first question to the audience. So Mark, if you want to take the lead here.
Yeah, thank you very much. Yeah, we just wanted to take a quick poll to help everybody as to their previous understanding, or is this really the first time you've heard about the Cheetah module? So if you don't mind just clicking on, we'll just show the results in a minute. So the quick poll says, have you ever heard before about Jinko's Cheetah module? Just literally select one, yes or no. Well, this is interesting. We've got a 39% response from the audience that they've heard of the module, and 61% saying no. So that's very interesting first impressions. So Andrea, back to you.
Very interesting, of course. And then I would say, yeah, then it makes sense to continue with the webinar and go into more details about the module series that we are presenting today. Cheetah series is a commercial name of a new cell technology that we developed at Jinko Solar. We named that also as a large cell module technology, meaning that the cell dimension is larger than than the traditional 6-inch cell that we are used to use today. The benefit, just to anticipate that, which will be the conclusion at the end of the presentation, the target is, as usual and as always, we focus on minimizing the LCOE of the system, because of course we, but not only we, it's clear that it's not enough anymore to talk about watt peak of modules, and not only module size and module watt peak, but to focus on the energy that the modules can produce, and ultimately the LCOE level that we can achieve with the different solutions. So the fact that the audience didn't hear much about probably the Cheetah series is due to the fact that it was launched recently at SNEC in China, so not actually a long time ago, so relatively new product, which is and will become the mainstream for Jinko Solar in 2019 actually. So a transition which has taken a few months, sorry. And will be completed and completely next year. So all the mono-PERC production for Jinko Solar will be focused on the Cheetah technology. So all the other mono-PERC modules supplied by Jinko Solar next year will be Cheetah series. Cheetah means rather a cell technology, module technology probably. So you can understand how that can be combined with different module configuration, different module technologies. That's the reason why we can offer that at both full cell and half cell format. Of course, the benefit of the half cell, which will be seen in the next slides, is even higher than the full cell configuration. But targeting, as you see here in this slide, almost 20% efficiency with the highest power class that we can offer at the moment. The modules, of course, rely on all the, as mentioned before, quality controls and third-party validations that also the other series are going through to offer really the highest possible quality and reliability of the modules, not only efficiency. I mentioned the possibility to have Cheetah series modules in both configuration, full cell and half cell. And here are summarized the main features of the two versions. Increasing the cell dimension, just to, of course, give you an idea, the current cell dimension that is used as mainstream in the industry is 156. In some cases 0.75 millimeters, compared to the 158 that we use for the Cheetah series. This allows to push up the power up to 8 watt at module level with almost the same module dimension. That, of course, as said before, the target is to reduce the BOS cost. You can imagine, you can understand how using higher power class modules, we can reduce the number of modules used for a given installation, peak power of installation, or even reduce the, for instance, the area needed for the installation, and that's clearly lowering the BOS cost. In the half cell configuration, on the other hand, we can boost up the power even more than a power class again. So combining Cheetah and half cell together, we can increase basically 3 power classes compared to the traditional mono-PERC standard size cell that we supply together. And one additional really high value on half cell solution is the lower temperature coefficient. The thermal behavior of Cheetah series, but also half cell series in particular, is much improved. We will see that in the next slides, but that gives a really tangible value in terms of energy production. Having improved temperature coefficients can really increase the performance and the energy production of the module during its lifetime. In these slides, we can see the roadmap, the power roadmap that we have on the Cheetah series. Now we are talking about 72 cell. We see that starting from next year, the maximum power class available will be 400 watts on a 72 cell half cell module configuration, combined with other add-on technologies like light reflecting ribbons or white EVA. Those technologies are used to increase the power range that we can cover with a given product series. So for instance, in this case, we can cover 4 or 5 power classes with the same basic technology, but adding add-on technologies at module level or combining with half cell technology. Again, the trend is clearly to go up. Every year we increase power class on the series. So 5 watts, additional 5 watts every year, of course, on Cheetah series as the other series. And talking about half cell technology in particular, to summarize about this, it was a product launched already quite a while ago, but just to recap on why it's possible to increase power class and power of modules with the half cell technology. Basically, the idea is that by splitting the cell in 2 parts, we can have the current going through each cell and combining them in a parallel configuration, basically having like 2 modules in parallel in one. We can have basically the same output values in terms of current and voltage at the MC4 of the modules, but internally the configuration of the modules allows to reduce dramatically the power losses that we have because of resistive losses in the connections in the cells of the module. So we are talking about, of course, tiny numbers apparently, because power losses, of course, are not related to only resistive or joule losses in the modules, but in terms of power class, as mentioned, we can go up to 1 or 2 power classes compared to the basic cell technology. So by using, for instance, the same cell efficiency and same cell technology, we can have modules with a 2 power class higher power bin compared to the basic technology. And that, of course, combined with the Cheetah technology again, that's what we at Jinko believe and focused on will be the new mainstream product for the next years. I mentioned about the temperature coefficient. Temperature coefficients are really key parameters to improve or control somehow the performance of the modules in the field, because of course modules are not unfortunately operating in the field at 25 degrees Celsius, but most likely at 70 plus during normal operating conditions. In those conditions, having even a tiny difference on temperature coefficients can play a significant role in terms of energy production. The normal standard monocrystalline modules that we provide can achieve minus 0.4% per degree Celsius power temperature coefficient. The mono PERC series already has an improved temperature coefficient, slightly improved, but the big gap is, as you see here, jumping to the Cheetah half cell configuration. With this module, the temperature coefficient can be really significantly improved, and the thermal behavior of the module, of course, is improved to give these results, to outperform the standard modules that not only Jinko but are available in not only Jinko supplies but modules that are available in the market. So quantifying the benefit of having an improved temperature coefficients, just to make a simple comparison, by using, for instance, same power class 280 watt peak modules in the 2 configurations, conventional full cell and half cell module, comparing the 2 temperature coefficients that the modules have, we can achieve a difference of 2 or 2.5% in terms of energy production, which we will see at the end will be reflected directly on the LCOE energy lifetime production of the modules of the system, and of course indirectly LCOE level that can be achieved. That's a reason why the combination of Cheetah series modules with Half Cell technology is probably the best fit or the best solution to significantly reduce the LCOE of the PV system. And Mark, time for the next two questions, I think.
Yes, thank you very much, Andrea. We have another poll that we'd like to just do, and just before we go on to the following slides, just to get an understanding from people on the webinar of how much space would you expect to save using the Cheetah series modules compared to, say, a normal monocrystalline module. So we've posted that up there. If you can do a quick poll, just give us an idea the range of the possibilities. Okay, this is very interesting. 25% believe it's around gain around 6%. The mainstream seems to be around 8%, but there's a very strong third of the poll that says the gain could be as much as 10%. So thank you very much for that poll. We also have another poll here because the next two slides are going to show why this is good to do. It says, how much extra power can you install by using the Jinko Cheetah Half Cell 400 watt peak modules compared to normal monocrystalline modules? Just please just select one of the buttons to press, please. Right. Well, there's a slight shift here. Very few think that it's only a 2 to 3% gain. The middle ground is very much a 5 to 6, but actually a lot more people are pushing towards the 7 and 8% extra power that they believe or perceive that the Cheetah half cell modules are going to produce. So thank you very much for those polls.
Thank you, Mark. And yeah, I'm glad to see the result, especially about the second question. And here is the answer. So fortunately, the main part of the audience was right. The additional energy that can be installed in a given area, it's significantly higher, and that's particularly important when talking about rooftop installations, for instance. That's a case we were clearly referring to. In this case, clearly having a much higher power class module, we are comparing in this case, for instance, Jinko Mono PERC 305 watt peak modules compared to JinkoSolar Cheetah 330 watt peak module. The additional power that you can have here is in the order of 7 to 8% of peak power, and that can make the difference when designing or installing modules on a rooftop, because in this way we can really save space available on the building, for instance. And of course, even why not save space for further expansions of the PV systems, which is not a usual to happen for revamping cases or repowering cases for rooftop or even utility or ground-mounted installation situation. This is the example of a system comprised of 20 modules, 60 cell format. We are talking about, in this case, of a 330 watt peak module. So we're talking about the Half Cell Cheetah series modules with the highest peak power possible to achieve a JinkoSolar at this moment. So as I said, the incremental power, peak power possible to be installed in this case is in the order of 7–8%. Now analyzing what happened in terms of area needed for a given installation or weight, which are two very important parameters as well for rooftop installations. The area, in this case, the answers for the poll questions were, yeah, I saw a few doubts from the audience, but it's clear that also here the area savings that we can have are really significant in the order of 6% for sorry, yeah, 6% for the Cheetah series. In this case, for example, we are comparing installation made with the same peak power and just analyzing how much additional how much area we can use to have the same installed power, comparing a mono standard 285 modules with the Cheetah 330 again with a half cell configuration. In this case, of course, both area needed and weight installed on the rooftop are significantly reduced, and that's the real benefit in this case. It can be useful point to avoid, for instance, shaded area on the rooftop, which would not normally allow to install modules in a given portion of the area, and of course use overall less surface for the PV installation. Moving to utility scale ground mounted situation now. Also in this case, it's really clear, of course, it's a higher order of magnitude. In this case, we are talking about a project of 100 megawatt size in North America, for instance, comparing an Eagle mono PERC 72 cell module with a Cheetah half cell 72 cell module. In this case, for instance, just quantifying the number of modules that can be saved, and you can see here a clear quantification of that figure, gives you the idea, of course, of why also BOS is decreased. BOS costs are lower simply because you need to install less modules for the same given power of the installation, and that's giving less components, of course, less cabling, combiner boxes, and all the BOS in general. BOS cost is reduced proportionally by having a higher power class modules. But also in terms of course, in particular mounting structure, you can see significantly lower mounting structure quantity, and area saving in the order of 3% also in this case. It's different figures because, of course, in the previous case, we were talking about a coplanar partially integrated situation on a rooftop. In this case, we're talking about a ground mounted installation. So the figures are different for this reason. And going into a little more details on the financial aspects of the benefits of JinkoSolar's Cheetah version, quantifying, for instance, for the previous case, what is the LCOE and IRR that it's possible to be achieved with 3 different type of products: the mono PERC, the Cheetah, and the Cheetah half cell. It's not a surprise the fact that the Cheetah half cell, as said already many times, offers the lowest possible LCOE. And of course, highest possible IRR. The energy production is increased, but not only. In this case, it's rather a matter of lower quantity of modules, lower BOS, which is directly impacting the LCOE level that is possible to achieve in this configuration and in this case. These are real case studies done, of course, with the help of simulation softwares and with the support of internal tools that very complex LCOE estimation tools that we developed internally, and we are happy to support our customers in case they might have more questions or they might want to go into more details about their specific projects they are developing, to evaluate what is possible to achieve with the Cheetah series models. Talking about LCOE and going back to the very initial comments about LCOE and how important is reliability to give a stable and really low LCOE is the reliability. So the scorecard program, the PQP program developed by DNVGL and every year repeated by DNVGL, is one of the programs that JinkoSolar takes part to. And as you clearly see here, JinkoSolar always qualified for the top performer class of for this kind of test. It's a very complex sequence of tests based on the IEC 61215 and other additional tests like LID, PAD, etc. So really complex and complete evaluation of how reliable and good quality modules are supplied to the market. We, of course, qualified in the last edition as a top performer, but that's not the only point. The other aspect is that we qualified for all the tests included in the test sequence. So all the test modules passed as top performer category, and also all the series were tested. So not only talking about mono PERC, but mono standard, poly, and all the series were tested for this protocol. And of course, we are following the same protocol also for the newest product in family, which are the half cell, half cut cell modules, and the Cheetah series, which we can produce today. So now, conclusion of the discussion and main point for the today webinar. We wanted to give a really concrete and clear estimation with really attainable figures about BOS and LCOE, US cost and LCOE level that can be achieved with different solutions provided by Jinko Solar. We compared here in this chart mono standard product on the left-hand side, Cheetah series in the center part of the chart, and polycrystalline modules on the right-hand side. So again, it's not a surprise that BOS cost with high power class modules goes significantly down. It's really clear that by increasing the power class of modules, same as it was possible with the switch from 1000 volt systems to 1500 volt systems, it's possible to reduce a lot the BOS cost by reducing, of course, the number of modules needed to be installed, reducing the components at BOS level that are needed to be installed for the same peak power of the installation. This was the case for a project in Spain, in Sevilla in particular, for a 40 megawatt AC project with ground-mounted fixed racks, and of course the trend of having even tracking systems or more optimized design can really even increase a lot this difference that we see here. The fact that the Cheetah and Cheetah Half Cell 390 in this chart don't have a significant difference in terms of BOS cost is given by the fact that by comparing the same power class of modules, basically the BOS costs remain almost the same, and there is not a major difference in the estimation. The calculation are based, of course, on PVC's software for the energy production in lifetime of the PV plant. So we used, of course, the PEN5 validated when available, or PEN5's set on Cheetah parameters for the Jinko Solar modules. The energy lifetime production for a Cheetah series, again, it's higher, especially for the half cell module, because of the improved temperature coefficient, which is a fact reflected also on the mono standard and polycrystalline module type, which is consistent with the fact that it's given by the temperature coefficient and mismatch or shading losses mitigation given by the half cell configuration. Last chart showing the summary of what's showing the previous two charts, and that's the conclusion and the estimation of the LCOE, the levelized cost of electricity or energy, based on our tool that we developed internally, very complex and very detailed, taking into account all the different aspects of the BOS, all the different components of the system, all the works and civil works, or even operation and maintenance activities, all the aspects included in this LCOE estimation to give the most accurate estimation of the level that can be achieved with the different module solution and module technologies. Clearly, the polycrystalline still has a chance compared to monocrystalline, monostandard modules, but it's clear that moving to mono-PERC and mono-PERC Cheetah and Cheetah Half Cell, the LCOE is really the lowest possible with this technology. And that's the reason why Jinko Solar will focus all production or main part of production on Cheetah, especially on the mono-PERC, which will be available in principle also on polycrystalline, but that's a kind of best fit with the mono-PERC solution, because it can really give the best combination of model performance and LCOE. So to summarize, increasing the cell size is clearly the trend now in the industry. We moved in the past from 5-inch cell to 6-inch cell, and now, of course, slightly enlarging the cell size not to dramatically change the model format, and therefore allow for a quite standard transition from the previous module CSPV systems design to the new module series that can be still used with the module configurations and module design that we were used to see in the past. And Cheetah modules, as we saw in the previous slides, really gives the lowest possible LCOE and the highest return on investments among all the single-phase PV technologies. Single-phase PV technologies, because of course, not taking into account bifacial solutions, which could be really significantly reducing even further the LCOE. But that's not the topic for today. And Half Cell technology, for sure, represents the best fit combined with the with the large cell Cheetah series version of the modules, because allows for really high advantage on the cost-benefit balance that can be achieved with this solution. And ultimately, we can achieve basically 2 higher power beams compared to the standard technology, and with improved temperature coefficients, which allow for really higher energy production of the modules throughout the lifetime of the PV installation. Last comment on our website, which have been launched recently. We have a new JinkoSolar.au website, which we really warmly invite you to visit, because it's full of information, especially about not only data sheets and PAM files, which we are really happy to publicly share with the market, so as to give you comfort about your estimations and simulations with PVCs, but also about module reliability, quality, and sustainability, which are all topics we at Jinko Solar pay high attention to, not only about module efficiency. And Mark, thanks. It's all for today. I hand over to you again for the conclusion.
Well, thank you there, Andrea. We actually have quite a few questions here. I've just been trying to sort out sort of duplicates, but I just want, before we go any further, quite a few people have actually asked about whether the presentations will be available or whether there's a copy of this. Just want to ensure everybody that everyone will get an email with a link to the fact that we post the presentation, we post the webinar on the PV Tech website as soon as possible, so that you'll be able to go back and go over all of this information at your leisure. So that's the first sort of admin side that gets rid of a fair few questions. Another trend in the questions was people trying to understand half cell technology, but that was just before really, Andrea, you got into some of that detail, but maybe just a refresh for people, just to express the difference between your large area P-type mono cell to the half cut.
Right, sure. I go back to probably the slides talking about half cell in particular. The half cut cell technology has been used already even before the new Cheetah series modules on the traditional standard cell size technology that we provide. But clearly, the benefits is at cell level, given by the fact that it is possible to increase the power class of the module by using a half-cut technology by more than one power class. So the main differences are summarized probably in this slide, comparing full cell and half cell technologies. The full cell technologies Cheetah series already increase more than one power class at module level. Combining that with the half cell configuration, we can increase even further the power bin of the module, and combining the two together, we can really increase 3 power classes plus at module level for this series. And as I said, the technology of the half cell is not new for Cheetah series, so it's used for different series of modules, as we saw in the general portfolio before. But here are the key differences. So peak power and also energy production, thanks to the lower temperature coefficients and better mismatch or shading mitigation that is given by the half-cut cell technology.
Okay. There's actually quite a lot of questions have come in since the Q&A started. Several talking really about, I think, I'm just going back to it because actually there's a lot here to just go through. Just confirmation that the Cheetah module series is actually P-type mono. It's not N-type. Don't think you need to answer that one there, Andrea. Some people are asking.
It's very easy and quick. It's actually all our series are based on P-type silicon at the moment. We are developing internally an N-type solution, but that's not available at the moment, and it will be probably only for bifacial series.
Connected to that, a lot on the module side, questions here about whether it's available only in frame or is it frameless. May answer that one.
Oh yeah, well, we tend to supply framed version, not bifacial, of course, because that's the mainstream solution and most reliable that we are used to supply. In principle, it is possible to produce glass modules. It's also, as you know, a matter of compromising between benefits and cost of the modules, because there is some differences on that level. But in general, Cheetah series comes with frame.
Right. Yeah. Not sure we'll get to some of these in the time, but one of the questions here: why is the balance of systems between Poly and Cheetah half cell? Why is this -7%, and the LCO difference is only 2.5%?
Yep. It's going back to the slide of the BOS. Yeah, you see here. So sorry, let me rephrase just in case, just to make sure I got it right. The comparison is between polycrystalline and Cheetah.
Yes.
Right. So the BOS cost for the modules represented here is clearly given by the power class. So as you can see here, probably by putting polycrystalline on the left-hand side of the chart, it would be more visible, but it's clear that it's directly proportional to the power class of the module. So the BOS cost is directly dependent to the power class of the module. The LCOE is, of course, not only depending on the power class of the module. So the connection, the relationship between LCOE and BOS is not one-to-one. And that's the reason why there is a discrepancy on the two charts and the two estimation. LCOE is a much more complex estimation, which takes into account all the financial and, as I said, not only BOS, but even aspects like operation and maintenance or civil works, or all the aspects needed to be considered for a PV system as a whole.
Right. Several people have been asking what type of volumes of the Cheetah series will be available for customers in Europe in 2019?
Oh, well, that's a good question, but the good news is that fortunately we don't have MIP anymore. So actually, the good news for us is that we can finally use all the capacity that we have in China available for supplies to Europe. So there is actually virtually no limit on the capacity available for Cheetah series. The limit is the capacity that we have on the cell technology. So as mentioned during the webinar, Cheetah series will be mostly focused on mono-PERC cell technology. We have at the moment roughly 5 gigawatt of capacity for mono-PERC, and we are expanding, heavily expanding next year on mono-PERC. All the expansions that we are planning for next years are focused only on mono-PERC. So there is virtually, just to be concrete, no limit on the capacity for the Cheetah solution.
Okay. Another one on the module side, is the 1500 volt system going to be available?
Yes, absolutely, and that's actually one of the mainstream we see, especially for utility scale ground mounted installations, is becoming a kind of standard solution for utility projects. And for instance, in this estimation here, we of course considered 1500 volt system solution, which of course allows for even lower BOS and even lower LCOE in the complete calculation, also in this example here.
Several questions are related to, obviously you talked about the bifacial, but it says one of the questions is, do you have any type of Cheetah modules but in the bifacial format?
That's a good question. I think I mentioned that while talking. It's in principle possible, because Cheetah mono-PERC solution is based on, of course, on PERC technology, which is the basis for our P-type bifacial technology as well. So we can be flexible, and our production lines can be flexibly adapted. The limit at that point is probably rather than the cell technology, the frameless or framed version for the lamination. But just not to go out of the topic, the target is of course to implement Cheetah version also on bifacial. Not yet available at big production, but next year will be rapidly expanding also the capacity for bifacial, also because we see a lot of interest from the market about bifacial solution.
Understood. Very quick response to this one. Yeah, okay, we've got several on that one, but yeah, just a quick confirmation on the actual size of the module. There's no I'm assuming, although you're using a larger area P-type mono wafer, the actual module size on the 400 watt module is no different to something conventionally acceptable.
It's absolutely conventionally acceptable. It's only a few centimeters taller and larger module. You can consider it's basically 2 millimeter wider cell. So it's just making. I'm sorry, I admit I don't know the dimension by heart. But if you go on the website, you can download all the data sheets and you can find all the features there. The only main difference can be on the half cut cell solution, because their model is probably slightly taller than the full cell solution because the gaps among cells is of course increased.
Another quick one, because there's one or two more sort of in-depth ones to hopefully we can get through in the next 3 minutes. Quick one is several people have asked, the assumption being that you're shifting completely to mono and poly won't be available.
Oh, that's not completely true. That was probably misleading what I said, but just to restate, the expansion that we are planning, it's focused on mono PERC. It doesn't mean that we are giving away all the production that we have at polycrystalline lines, which is still significant because it's still in the order of 4 or 5 gigawatts per year. So that production capacity is not planned to be dropped, to be cancelled. Actually, the plan is to improve it. So there is a lot of studies also on polycrystalline technologies going on, and we believe that that part of production will still play an important role, but for sure, for expansion plan and Cheetah in particular, will be mainly mono PERC solution.
This is an interesting one. Are the half-cut modules more or less sensitive to PID and or micro cracks?
Well, the PID resistance of our Cheetah series is the same as our previous Eagle series. So the modules are tested and produced against the highest resistance against PID. So modules are all PID certified, offering the highest possible PID resistance to the modules. And regarding micro cracks, we have, of course, at micro crack level, a very strict quality control procedure, starting from ingots, wafers, and throughout the value chain that we control internally, which is also the reason why we can control crack patterns and crack developments very, very accurately. We even carried out transportation tests and transport and packing in certification to make sure that really modules are delivered down to the PV site in the best possible condition.
Right, well, sorry to say that's all we have time for on this webinar today. Our time has run out. Thank everybody for coming on to the webinar. I hope you've found it interesting. Certainly the amount of questions we've had, we couldn't get through all of them, but just to reiterate that PVtech will be posting the webinar on the website with the presentations. And of course, if people are talking about wanting to know prices and more technical details about the modeling and simulation software and the calculations, then Jinko Solar asked that you contact your local representative on that, but obviously it was all referenced here with the webinar. So Andrea, thank you very much for such an interesting presentation, and hopefully we'll be back soon with a new webinar soon. Thank you very much. Bye-bye.